Okay, welcome back. This is section 2, and this is a section about similar figures. And what I talked about earlier was similar figures are figures that are the same shape. So we're the same shape, but different size. But different size. Okay, so let's, and really what that comes from is a transformation. Okay, that comes from a dilation in the plane. All right, where Q is the center of the dilation, this point here, and N is the scale factor. Remember, if N is larger than 1, okay, if N is greater than 1, then it's going to get big. If N is between 0 and 1, then it's going to get small. Okay, so we talked about that in the last unit. Let's go ahead and kind of talk a little bit more. And let's just kind of talk for a second about something. Let's talk about these coordinates here. All right, and what this says here is that we take the dilation about the origin by a factor of 2. Okay, here's my segment AB. Here's my segment A prime B prime. Okay, now the coordinates for say point A, okay, is the point 2, 1. Okay, but what happens when you go to A prime? Okay, well that's really just the point 4, 2. Okay, and so what you want to say here is, how do you go from point A to point A prime? Well, if you take 2 and multiply it by 2, take 1 and multiply it by 2, then that's going to give you the points 4 and 2. Okay, similarly with the points B, B is the point 2, 3. And what do we have to do to get to point B prime? Well, that's just going to be 4, 6, okay? And so again, if you multiply 2 by 2, you're going to get 4. If you multiply 3 by 2, you're going to get 6, okay? Now the length, if we talk about AB, all right, AB has a length of 2, all right? From 3 to 1, that's a length of 2, okay? And then, but what about A prime, B prime? Okay, that has a length of 4, okay? So what do you have to do to 2 to get to 4? And you simply have to just multiply it by 2 to get to 4, all right? But 2, guys, is our scale factor, and we know that N is equal to 2 because it tells us, okay? Now the slope, okay, of AB, okay, so AB, that slope is undefined, okay, because it's vertical, okay, it's just no rise, no run, okay, and the same thing about the slope of A prime, B prime, is that those slopes are also undefined, and these are the same, okay, and we know that these segments must be parallel if it's a dilation, okay, so let's, kind of talk about this real quick. It says finding the vertices of the preimage. And instead of saying preimage, that's the OG image, okay? And if we're given the dilation rule that, if we're dilating about the origin, okay, so I'm going to label that O as the origin here, okay, and then our scale factor N is equal to 2. Okay, now what I see here is that I have E prime F prime has a value of 4. Okay, and if I wanted to dilate about that point, the origin, which is lying on point E, okay, I know that this length here, which is 4, okay, if it was 2, all right, means that this is the larger version, that the original one had to have been smaller by a factor of 2. Okay, and so because we have a length of 4, what number multiplied by 2 gives me 4? And that's a value of 2. So I'm going to put a point 2 here and call that point F. And this original point here, the origin is point E. Okay, same thing here with this point here, which is from E prime to G prime. I want to cut this in half, okay? And I'm going to plot a point right here, cutting that in half, and this is point G. Same thing over here from E to H, okay, half of that, and H is the point 6, negative 4, so it's going to be 3, negative 2, it's going to be down here, okay, so 3, negative 2, and that's going to be point H. And so that, my friends, is R. Okay, what are the vertices? So let's write these down, okay? So I know that point E has the point 0, 0. Okay, I know that point F had the point 2, 0. I know that H had the point 3, negative 2. Okay, and I know that G had the point 1, negative 1, negative 2. Okay, now if I were to talk about my preimage, okay, or this is my preimage, okay, this is the OG, but now let's talk about the image, because you were given the image, all right? I know that E prime had a value of 0, 0, okay? I know that F prime had a value of 4, 0, and that H prime had a value of 6, negative 4, okay? And then G prime had a value of negative 2, negative 4, okay? And what I want you guys to see is that to go from each of these points, you had to multiply each of these by 2 from your OG to get to your image to get those points, okay? And that's how we get those, all right? So, but in similar figures, okay, here's what we know. Okay, similar polygons are two or more polygons in which corresponding angles are congruent and the sides are proportional. So the angles are congruent, okay, and the sides are proportional. Proportional, okay? In layman's terms, this means same shape but different size. Same shape but different size. Okay? And so that's what I've got, all right? And what we know, okay, show that the corresponding angles are congruent to prove dilated figures are similar. So what I know is I know that AB is parallel to A prime B prime, okay? I also know angle 1 is congruent to angle 4. Angle 2 is congruent to angle 5. That's the big one. That angle 2 is congruent to angle 5. And you know, that's pretty much, you know, there's other stuff going on here to talk about those all adding up to 180. But you know what? All I'm really concerned about is, you know, you just understanding this, is that angles are congruent, sides are proportional, and that in layman's terms, similarity means same shape but different size, okay? In proportional, let's talk about that. That means a fraction. Okay, fractions are equal. Okay, and that's pretty much it, all right? All right, let's move on to the next page. Let's kind of look at some things. All right, so, you know, let's talk about corresponding parts of similar figures, okay? If we talk about dilations with the center at the origin, okay, that means that we're going to have this transformation of a dilation about the origin of a scale factor of n. And to go from one point to the next, we take each of those values and multiply it by the scale factor. Okay, we know that the segment lengths are proportional to n. Okay, and so then we want to know, and we also know that the segments are parallel. So what I know, let's talk about corresponding parts. Okay, so corresponding, let's talk about corresponding angles. Okay, and we know that corresponding angles are congruent. Okay, so here's what I've got, that angle E, okay, angle E corresponds with angle M. Okay, E is in the top left, M is in the top left. So angle E is going to be congruent to angle M. Okay, I also know that angle G is in the bottom left, and so is angle K. So angle G is congruent to angle K. All right, and I know that just because they're right angles. Okay, you can kind of just tell. I also know that angle H is congruent to angle L. Okay, so angle H is congruent to angle L. All right, and then I also know that angle J is congruent to angle F. So angle J is congruent to angle F. All right, now let's take a look at what the value of the segment lengths are. So what's the segment length of EG? So corresponding angles, let's look at corresponding sides. Corresponding sides. All right, what I want to do here, all right, if I take a look at, say, segment EG, from 4 to negative 2, this is a length of 6, okay? That means that FH is a length of 6. GH is going to go from, what is that, negative 5 to 3, that's 8, okay, and that's 8. MJ is going to be a length of, oh dear Lord, 1.5 to negative 2.5, which is a total length of 4, okay? That means that KL is also going to be 4, and then that MK is, what is that, from 2 to negative 1, that's a length of 3, and this is a length of 3. Okay, so here's what I know. Okay, I know that EG, all right, let me write down these segments. EG, GH, HF, and FE, okay? And I know that EG is 6, so this becomes 6. This is 8, this is 6, and FE is 8, okay? And then let's do the same thing. Let's do MK, all right, MK, let's do KL, and let's do LJ, and then let's do JM, okay? Now, there's a reason why I'm kind of going around in this way, is to kind of show you that these sides are proportional. So remember, MK, what we found out, that's a value of 3, okay? Value of 3, KL had 4, LJ was 3, and JM was also 4. And what I notice is this, is that, you know, we want to dilate this by a factor of 0.5, okay? But I wanted to just kind of show you guys how we got that. So if we take EF, EGHF, so I'm going to say parallel or quadrilateral, okay, EGHF, okay? Notice how when I name this, I go around the figure, and I know that that is similar, okay, and that's my symbol for similar. It's just that little tilde. Okay, congruent meant that you had equal signs underneath, but similar means that you just have that tilde there. And that's similar to, and I'm going to match these up. So EGHJ matches up with MKLF, okay, and we have to write it that way, okay, and that's MKLF. And because it gets smaller, because EGHF is the bigger one, and this is smaller, then I know that my scale factor n is equal to 1/2, or n is equal to 0.5. Okay, it has to be a fraction because it gets smaller. But what I want you to realize is the naming, that E and M correspond. So when I write my similarity statement that E and M correspond, they go in the same spot. Okay, same thing with G and K. G is next, K is next after that. Same thing with H and L. Notice how H is there, L is there, and then J, F follow up. No, this should be J, sorry. My bad, wait. No, it's the other way around. Dang it! J and F, wait a minute. Yeah, sorry, this should be F, my bad, and this should be J, okay? This should be an F here, that figure there, and that last one should be a J. My bad, I apologize, my bad. Yeah, easily can get confused and all that. So, okay, let's go on. Let's talk about center of a dilation that is not at the origin. So on this one, we have our OG segment, which is EF, and that's a dilated about point G, and that's not at the origin. Okay, this is our center of dilation, and then you know what I want to do is increase this by a factor of 2. Now we have some things that help us figure out what this is, and what I want to do is I want to draw new coordinate axes centered at point G. So what I'm going to do here is I'm going to do this. I'm going to draw an axis here and an axis here, okay? And then what I want to do is find the coordinates of the preimage in the new coordinate system. So if I think about this as my x-axis and this is my y-axis, then what I've done is I've gone over 1 and gone up 4. So F has the point negative 1, 4. Okay? And then point E is the point, what is this? 1, 2, 3, 4, up 1, 2, 3, 4. E is the point 4, 4 as well. Okay? And what I want to do is take my scale factor, and that's a scale factor of 2, n is equal to 2, and multiply it by each of these. So what happens is that I get that f prime is going to be, if I take negative 1 and multiply it by 2, it's going to give me a value of negative 2. Okay, if I take 4 and multiply it by 2, that's going to give me a value of positive 8. Okay, and then if I wanted to do E prime, okay, then I would just take, I would have 4 and 4 multiply each of those by 2, and I'm going to get the point, and this should be, I'm sorry, this is negative 4, negative 4. So then my image should be negative 8, positive 8. Gosh, I'm all over the place today. This is a positive 4. Okay, so now what I want to do is I want to plot those points on this new point, on this new plane here. So negative 2, okay, positive 8, 1, 2, 3, 4, 5, 6, 7, 8 is here, and that's f prime. Okay, so that's that point here. I'm going to call that f prime. All right. And then E is negative 8, negative 8. So I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8 and go up 8. And that point is all the way up here. And this is going to be E prime. Okay, and so then I'm going to connect those and create that line here. Now remember that EF, okay, if you just had your OG value, EF had a length of 3. Okay, so if I want to increase this by a factor of 2, that means that E prime F prime is going to have a length of 6. Okay, it's going to have a length of 6. So let's do that. Let's do 1, 2, 3, 4, 5, 6. So we're good. So that's a length of 6. So to get from 3 to 6, we had to multiply by 2. The other cool thing about this is that if I connect F prime and F and keep going, it'll bring me down to point G. Same thing with E prime and E. That'll bring me back down to point G. So that's what we got going on. All right. The dilation rule, and this is page number 2. Okay, this last one is applied to triangle ABC where the center of dilation is at point 1, 1. All right, so what I'm going to do is I'm going to draw some new axes here real quick. All right. And we want to increase this by a factor of 3. Okay, so A is now the point, okay, with my new axes in here, is the point negative 3, or I'm sorry, yeah, negative 3, 1. Okay, so that's negative 3, 1. Point B has the value of negative 2, negative 3. So this is negative 2, negative 3. And then C is the point 1, 2, 3, 4, down 3. So negative 4, negative 3. Okay, and what I want to do is get my new points. So that's A prime, B prime, and C prime. All right, and so A prime, you know, if I multiply each of these by 3, that's going to give me the value of negative 3, or I'm sorry, negative 9, 3. So A prime is going to be negative 9, 3. Okay, B prime is going to give me, oh, what is that? Negative 6, negative 9. If I multiply each of those by 3, and then this is going to give me negative 12, negative 9. Okay, and so, you know, if I don't even think I have those values. Okay, 1, 2, 3, 4, 5, 6, 7. Yeah, it's going to be way down here. So, you know, the image would look something like this, roughly speaking. Probably shifted over quite a bit more. Actually, way more. Hold on. It would be, you know, let me do one of those things here. All right. So if I did like that and like that, okay, makes those a little bit bigger. So that's the idea, okay? You know, when you have the points here, and you can plot them on a graph if you wanted to, but that's the idea. So I hope you enjoyed this video. I know it's a lot of kind of tedious stuff, but it is important that we understand dilations and why we get similar figures, okay, as opposed to just saying that we get them. So I hope you enjoyed this, and we'll see you in a bit. Thanks. Bye.